Some engineers in the tech industry eventually earn more than $250,000. Many others remain closer to $130,000. Both groups may write code every day. Both may work inside successful companies. Both may have similar years of experience, yet their careers diverge dramatically. The difference rarely comes from intelligence, and it rarely comes from effort alone. More often, it comes from where the engineer operates inside the system. Some engineers build features, others shape how the system itself behaves, and companies tend to reward those two positions very differently. Now, salary breakdown. What is important to understand is that these higher salaries do not appear evenly across the industry. Most engineers spend the majority of their careers between $120,000 and $170,000. That range represents the center of the software engineering labor market. Reaching $200,000 or more usually requires something different, either deeper technical specialization, greater architectural responsibility, or proximity to systems that the entire company depends on. In other words, the jump into the highest salary tier rarely comes from incremental improvement alone. It usually comes from a shift in the kind of problems an engineer is responsible for solving. Across the United States technology industry, many software engineers begin their careers between $110,000 and $140,000. After several years of experience, salaries often rise into the range between $150,000 and $180,000. However, the jump beyond $200,000 usually happens only in specific roles. Engineers responsible for platform systems, large-scale infrastructure, architecture decisions, or technical leadership often move into compensation ranges between $200,000 and $250,000. At this level, companies are not simply paying for code. They are paying for influence over complex systems. Now, market demand. Large technology companies depend on enormous software platforms, cloud infrastructure, data pipelines, platform engineering systems, and distributed architectures support millions of users every day. These systems must remain stable even as products grow and change. Because of this, companies constantly need engineers who understand how large systems behave. Demand therefore remains strongest for engineers who can work close to infrastructure and system architecture. These engineers influence how entire platforms scale. Now, competition level. Competition across the technology industry has grown significantly over the past decade. Thousands of developers entered the field during the expansion of software careers. Many focused on product development, application logic, or user-facing features. At the same time, modern development frameworks allow teams to ship new features faster than ever. This means companies do not always need large numbers of engineers working on product code, but the number of engineers capable of designing reliable large-scale systems remains smaller. This imbalance often explains why some engineering paths lead to higher compensation. Now, junior reality. Most developers begin their careers building features. They work on application code, user interfaces, and smaller components of larger systems. This stage is essential because it builds practical experience. However, engineers who remain permanently in feature development often encounter slower salary growth later. Developers who gradually move toward infrastructure, reliability engineering, or system design often gain access to larger responsibilities. These roles affect how entire systems operate, and that influence tends to accelerate career progression. Now, long-term outlook. Software systems are becoming more complex every year. Companies now depend on distributed systems, massive data platforms, and global cloud infrastructure. These systems must operate reliably across millions of users. Engineers who understand system behavior at scale will likely remain valuable across many industries. Even as programming languages and frameworks evolve, the fundamentals of distributed systems and platform design remain relevant. Now, positioning strategy. Another important factor is visibility inside the organization. Engineers working close to infrastructure or platform systems often interact with many different teams. Their work supports the productivity of dozens or even hundreds of developers. Because of this, their decisions tend to affect large parts of the company. Over time, this creates a reputation effect. When critical systems must be redesigned or stabilized, these engineers are often the ones trusted with the responsibility. That level of trust is one of the hidden drivers behind the highest compensation levels in technology careers. For engineers thinking about long-term career growth, the key concept is leverage. Which roles influence the largest portion of the system? Engineers working close to infrastructure, platform systems, reliability engineering, or architecture often affect the work of many other developers. Their decisions determine how systems scale, how failures are handled, and how future development happens. Working closer to this technical core often leads to both higher responsibility and higher compensation. Now, risk and resilience. No technology career is immune to economic cycles. Hiring slows, companies restructure, some technologies disappear. But engineers who understand fundamental system behavior tend to adapt more easily. Knowledge of networking, distributed systems, system reliability, and platform architecture transfers well between companies. This adaptability creates long-term career resilience. Now, final verdict. Some engineers reach $250,000 not simply because they code better. They reach it because they operate closer to the core systems that entire companies depend on. Roles that shape infrastructure, platform architecture, and system reliability create enormous leverage. And leverage is what most often drives the highest salaries in modern tech careers.